Hello there, proximity math here, and we're going to go over the 2018 SMT Calculus number 9. Okay, so it's asking us to compute this integral. We have sine here, so we can write this as 1 minus 2 sine squared of x, so that we only have sine x and x. Okay, so because both sine and cosine in the integral might make it reverse, this will become 3 plus 1 minus 2 sine squared, which is this minus 4 minus 2 sine squared of x, and we can divide out this 2 minus sine squared of x. Let me just move this over here. Anyway, dx, we have x sine of x over 2 minus sine squared of x. Well, alright, we could simplify this to 1 plus cosine squared of x, but we can actually use something called King's rule. Okay. Now, what does King's rule say? It says that if we have an integral from a to b of f of x, then dx, then that would equal to the integral from a to b of f of a plus b minus x. And this is a very handy rule, King's rule of integration. Okay. And this works because all you're doing is taking, since x starts at a and goes to b, this is going to start at b and go to a. This whole value is going to start at b and go to a. So you're just integrating backwards. It doesn't actually change anything. So anyway, that's not important how to understand it, but we can apply it and use sine of pi minus x. And that's actually just sine x. But the x term will become pi minus x. So if we let this equal to I, then we have I is also equal to the integral from 0 to the pi, 0 to pi of, okay, 2 minus sine squared of x is going to stay the same, because sine of pi minus x is still sine of x. But we have pi minus x here, and sine of pi minus x, which is sine of x. And this is going to really help us because the sine x stays the same, the sine x terms, but not the x term. Okay, so that means if we add the two different forms of this integral, then we can easily cancel out the x's and taking the pi outside will give the integral from 0 to pi times pi of sine x over 2 minus sine squared of x. Okay, we can use substitution because this is now a really simple integral. Using the Pythagorean identity, we can simplify this to here because it's 1 plus 1 minus sine squared of x, which gives this. And now we can use u substitution. U is going to be cosine of x. U is going to be cosine of x. Gives from 0 to now cosine of pi. We have 1 to negative 1. Yeah. Of, well, the derivative of this is actually negative du dx because the derivative of cosine, which is the very recognizable arctangent derivative. And actually, this is 1/2 of the integral we want to find because we have I. But we're adding the two different forms of the integral to get this, and we canceled out the x's. So you have to average these and divide by 2 to get I, which is what we want to find. So we have 1/2 pi times the arctangent from 1 to -1, because cosine goes from 1 to -1 as x goes from 0 to pi. And that is going to be negative pi over 4 minus pi over 4, which is a negative pi over 2. We also have this negative, so don't forget about that. And then you can cancel these out. 1/2 pi times pi over 2 is going to be pi squared over 4 as our final answer. Thanks for watching, and I hope to help you.